In machine learning, we have set of samples. We also call it documents. So it's a 2D, it's a table kind of a structure where there is row and there is column. So row is like row are documents or samples where the columns are features. Okay. So in machine learning, what is the partial derivation? What is the partial derivative of dot product of two documents? Okay, so if there are two documents and suppose a document U and document V, then each document is kind of each document vector has components as per the feature. If feature is 1, 2, 3, 4 up to M, so then U1, U2, U3 up to 1M is the component of U vector, and V1, V2, V3, Vm is the components of V vector. What is the partial derivative of dot product of two document vectors in machine learning? So this is the question. Okay, what is derivative? Means what is a differentiation? I have a variable called x. X is independent variable. I mean, it varies independently. It is not dependent upon anything. Now, there is a function called fx. X, fx. X is independent variable. Whatever is generated through fx is dependent upon x. What is dfx by dx? Differentiation of fx with respect to x. What is that? So that is unit of change, means number of unit that is changing in fx when one unit of change is happening in x. Dfx by dx. If one unit of change is seen in x, then how many units of change will be seen in fx? So that is dfx by dx. What about dfxy? X and y are two independent variables. Then fxy means fx comma y is a function. It is called multivariable function. It is called multivariate function. Since it is dependent upon two variables, x and y, two independent variables. We will talk about independence. Okay, that is another history. Okay, so there are two independent variables, x and y, and there is a multivariate function fx comma y, fxy. Then how much fxy would change with respect to change in x? That is partial derivation of the multivariate function. So dfxy, dfx comma y, dfxy by dx. If there is one unit of variation in x, that is partial derivative of with one of the independent variables, then how much fxy would change? So that is the straightforward question. X, fxy is x dot y. So x is a vector and y is a vector and fxy is x dot y. After all, it's a function, then it will come in some kind of equation. So fxy is x dot y. What is dx dot y by dx? This is partial derivation of dot product of two vectors. If now we will go with the dot product of x and y. X dot y is x1 y1 plus x2 y2 plus x3 y3 plus x4 y4 means multiplication plus xm ym, where 1 to m are components of x and y. So if there are two vectors x and y and their fxy is x dot y, then derivative of x dot y dot product of x and y vector with respect to x partial derivation is multiplication of each components, and then we have to add it. x1 y1 plus x2 y2 plus x3 dot multiply by x y3 plus x4 multiply by y4 xm multiplied by ym, x1 y1 plus x2 y2 plus x3 y3 plus x4 y4 plus x5 y5 plus xm ym. Now I have to calculate differentiation of this with respect to dx. Now since it is addition, then we can do differentiation one by one. So dx1 y1 by dx, dx1 y2 dx2 y2 dx2 plus like this. Now if I do, then it will come as dx1 then as per the multiplication in the derivation, then it will come as y1 dx1 by dx1, that will come as y1 into x1 dy by y1 dx1 plus y2 dx2 by dx2 plus x2 dy2 by dx2, like this. Now dx1 by dx1 is 1, so x1, so I am leaving x2, x3, x4, xm, only xm, x1 I am tackling, x1 derivation of x1 and y1. So it will come at x1 plus x1 into dy1 by dy dx1. Now x and y, suppose x and y are real axis, real orthogonal to each other, means the way we take coordinate axis, like in Euclidean space typically we say. So now the x1, x2, x3, x4, xn all are orthogonal to each other, then typically it will be 3 only maximum. So xi, xj and xk, so 3 components. Now if we take the ith component derivation, then it will come as x1 plus it will come as y1 plus x1 dy or y1 plus x1 dy by dx. So that is 0, means y and x are independent of each other, anyway they are orthogonal to each other. So the derivation of two independent variables, means x and y are independent, they are orthogonal to each other. So the partial derivation of dot product of two orthogonal vectors is next vector. So dx dot y by dx is y. Okay. Now we understood that what is partial derivation of dot product of two orthogonal vectors with respect to one of the vectors. Now question arises, what is partial derivation of two document vector in machine learning, dot product of two document vector with respect to one vector? Now u and v are two document vectors. So if I go by for u1 and v1 only, not u2, v2, means they are, so u1, v1 plus u2, v2 plus u3, v3, these are the features up to um and vm. So u1, v1 if I take, then it will come as v1 plus 0, so v1. So the partial derivation of dot product of two document vectors, okay, is the other vector, but there is a good job, it's not that straightforward. U and V has to be orthogonal to each other. When I say orthogonal to each other, each features, they must not be interrelated to each other in any fashion. Change in one variable must not change other. Okay, I believe it is called a multilinearity. So one feature must be exactly independent of other. If there is change in U, it must not bring any change in Y. If that is the case, then dot product of two document vector derivation with partial derivation with respect to one of them would result in other document vector. Otherwise, what would happen? If U and V document vectors have component 1 to m, and these components, these features are not completely independent of each other, like x and y we saw when we dissociated to I, j and k, then where they were independent of each other, because I, j and k are orthogonal to each other, so they are independent of each other. So x vector I dissociated into I, j and k in Euclidean space, and y vector I, j and k. Now x I y I plus x j y j and z k plus x k and y k. If I differentiate, then it would land up in y. So x dot y partial derivation with respect to x is y. But if I take two document vector u and v, then it should result, if I differentiate with u, it should result in v, in the sense that its components, means all the features u1 v1, u2 v2, u3 v3, these are the components, they should be orthogonal to each other. If they are not orthogonal to each other, it won't result in the next one. Okay, so can we land up into kind of dimensionality reduction, top class? And if they are interrelated, not independent of each other, then it would result in other vector. Otherwise, what we would do? How we can find that how it should move away? I mean, we can think about it.